Alrighty, hey everyone. Here are your video notes for our next section in our unit, which is wave interactions. We've spent the last couple of weeks talking about the different types of waves, and right now we're not so much worried about mechanical and electromagnetic waves. We're specifically going to hone in today on light, and I'll talk a little bit about sound, but we'll also do sound waves with the next week's material. But grab a piece of paper, get it ready, and we're just going to move through these three types of wave interactions. The first type of wave interaction that we're going to talk about is reflection. And this, by definition, is the bouncing back of a ray of light, sound, or heat when it hits a surface that it does not go through. Okay? Bouncing back. Pay special attention to the... Whoop, that's not what I wanted. Pay special attention to the bouncing back here. Now keep in mind, it can be in terms of light, it can be in terms of sound, or it can be in terms of heat. We're really going to focus on the light and the sound for the next couple weeks. So more on reflection. When we have light waves reflecting, that's what we know as a mirror. You've got a mirror in the bathroom of your house, you've got a mirror maybe in the hallway. You've seen mirrors before. And I'm going to bring your attention down here to this bottom bullet. Waves reflect back at the same angle. I cannot emphasize that enough. Waves reflect back at the same angle. So try this. Go find someone in your house, go find a friend, find a parent, and go stand in front of preferably a bigger mirror. And try to talk to that person by only looking at the mirror. And what you'll realize is, whether they're on your left or whether they're on your right, they appear in that mirror in the exact same position they are away from you, it's just reflected back. That's because of those light waves reflecting back at the same angle which they hit the surface. If we were to take a laser pointer and shine it at different angles with a mirror, it's going to bounce off at the same angle with which it hit. In terms of sound waves reflection is what we know as an echo. You yell at a wall, and when it yells back at you, that is the echo. It's the sound waves bouncing off at the exact same angle with which they hit. Our next type of wave interaction is what we call refraction. Okay, don't get this confused with the rarefaction, refraction. This is the bending, okay? So the bending of a wave as the wave passes between two substances in which the speed of the wave changes. All right, substances. Dadgummit. Substances. I want to bring your attention to substances. We're going to use substances as a medium. Okay? And keep in mind, medium also refers to matter. All right? Waves can pass through a solid, a liquid, or a gas. Okay? The sunlight that you see it passing through a gas if you're standing outside. If you're underwater in a pool, or if you're standing above the water, you can see the bottom of the pool because of the light waves passing through the water. If you're inside and you're looking out the window, you can see the sunlight passing through that solid. With refraction, this picture that we have here on the left, we're shining the light in at this angle, and you can see how it comes out. If I were to just take, I'm going to make this a little bit smaller. If I were to take and draw like a path of a trajectory, you would think that it would come out here, yes? But instead, this solid piece of glass that we've got there takes and bends the light to where it actually comes out here at the top, okay? That is refraction. That is the bending of the wave. The same thing is illustrated in this picture on the right, where we've got the straw in the water. If you've ever put a straw into a glass of water, it looks as though the straw is broken. Is the straw broken? No. It's just the fact that the particles in a liquid are so much closer together that it takes a little bit longer for those waves to pass through. We alter the speed of the wave, it alters the appearance of the wave. So that is what's happening with refraction. If you've ever gotten to work with a prism, when you rotate a prism, you see the rainbow. That's refraction. Even if you're just driving down the road or standing outside and there's a rainbow, that is the light bending through those water particles that are in the atmosphere, giving you all the pretty colors that you know as a rainbow. Okay, so that is refraction. Keep in mind, refraction is the bending of a wave. All right, light waves refracting. Oh, hey, look, there's the rainbow. Sound waves, if we have sound waves that refract, that's what we call distortion. So if you've ever talked through a box fan, so you stand behind a box fan and like are talking to your friends through it, and it sounds really, really weird, that is the refraction. You're bending the wave through a different medium. In that case, they're bending around the solids. Okay. And then our last wave interaction that we're going to talk about today is diffraction. And diffraction is a change. It's a change in the direction of a wave when the wave finds an obstacle or an edge, such as an opening. Okay, and we've got some really pretty pictures here, which is, and you could argue that this one on the right, where we've got, I'm talking about this one right here, where we've got the rainbow patterns going on. Yeah, there's a little bit of refraction happening here, but you notice that it's going off in so many different directions, and that's because with diffraction, we've got the change in direction. Here, I'm going to go ahead and go to these examples. When you've got light waves diffracting, if you've ever gotten to play with a kaleidoscope, so those fun little things that every so often they would give out in like Happy Meals at McDonald's, you look, you turn it up to the light or you spin it around and it's got so many different lenses and things in there that everything just gets distorted. Or if you were in class and you were doing this right now, you would see 100 Fagans or 6 Rogers or something because of how you turn the kaleidoscope. That's the diffraction. It's the wave bending around stuff. If we've got sound waves diffracting, it's your ability to hear your mother in your room right now when she's all the way down the hallway, or she may be in the kitchen. She doesn't have a direct line of communication with you just straight. The sound waves have the ability to bounce off of all the different walls, and no matter where you are at in your house, your mother will still be able to make her wishes known. Alright, so to summarize, let's wrap this up here real quick. We've got 3 ways. Oh, that's really big. My handwriting will not work that way. 3 ways for waves to interact. Wave interaction. Okay, 3 ways for waves to interact. Okay, our first one is reflection. Okay, then we have refraction. And then we've got diffraction, maybe. And if there's anything that you're going to remember from each of these, okay, reflection is the bouncing back. Keep in mind, it's a bouncing back at the same angle. Okay, refraction is the bending. All right, think pretty rainbows. And diffraction is a change in direction. Okay, those are your 3 types of wave interactions. If you've got any questions, please feel free to contact either Coach Powell, Mr. Fagan, or Miss Rogers, and we will be more than happy to explain this further.